Welcome to our course about neural network, and in this part of our lesson, we are going to talk about a single neuron. So basically, a neural network is composed of, shall we say, many equations. That is, if we're going to make it more complicated, but basically, it's actually a single neuron, which is just a single linear equation function. So if you know linear equation, I think you would easily understand what we mean by a single neuron. We have here on the left side a simple representation of a neural network. So in this case, there is just only one linear unit, and that is equals to y equals to wx plus b. I don't need to discuss what this equation is all about, but basically this is a linear equation. Whatever values we have on the right, wx plus b, then that would result to the output y. So in this case, we have an input x, and that is it has its corresponding weight, and then we add the value of b, which is bias, and then when we add the b to the x, then we would come up with y. So in this case, the input x connects to the neuron with a weight w. So this value actually passes a single connection, and then it is multiplied by w, and then after that it receives w times x, and then that's from the input x. In this way, the neural network learns as we update these weights. What do we mean here by weights? Basically, weight is something that we need to tune by the moment when we want our model to have an optimal performance. So that's something actually that's based on experimentation, and which is also depends on the result and the needs of our case. So here in this case, the bias is denoted by B. This is actually a type of weight. So unlike other weights, so this is not actually tied up to any other value. Instead of one, which is used here in the diagram, the value that makes or the value that reaches the neuron simply P. So this allows the neuron to adjust its output independently of the inputs. So for us to be able to properly understand what I am talking in this case, let's go to how it is being coded using Python. So now we have here actually a representation of neural network, how it is used or how it is modeled using Python. This is actually from scratch. Let's discuss for some of the terms that we need to really understand. So apart from the one we discussed just a while ago, we first have to understand the nitty-gritty and the different terms connected to the proper understanding of how a single neuron works. The input will either be actual training data or the inputs from the previous layer in the neural network. In any model, we of course need data for us to be able to train something, right? And for us to also have results. So in this case, when we talk about the neural network, data can be the actual training data, or it can be the results coming from the previous layer. Be mindful that when we say neural network, it's composed of many different layers, and each layer is different function. So each function has its own output, and that output is then passed on to the next layer, which is then processed. So if you could remember, I have said that a neural network is actually composed of many layers, and each layer is actually a function, which is basically a linear regression function. It can be other functions, or it can be a more complicated type of a linear regression function. So basically, that's how it works on a higher level. So inputs, it is the data passed into the model to generate the desired outputs. Then we have the weights, parameters in the model that are adjusted during the training to achieve the desired results. So in a way, the bias is actually also a weight because this is adjusted as we tune the model to arrive at a certain desired results. So the training phase, this is actually a process where the model learns by adjusting its weights and biases. This is what I've said. Weights and biases, these values are within the model that change during the training process to optimize performance. These are actually not part of the data, but these are standing independently of the data themselves because they can just be adjusted during the training phase. So the model training, this is actually the process where weights and biases are tuned, so determining the model's effectiveness in producing the accurate outputs. This is very, very much true because in the process of the model training, weights and biases are very important, so they have to tune. That's why model twinning, it's actually a repetitive. It's actually very iterative because you really have to repeat twinning the model, adjusting the weights, the biases, and other parameters. So more about the parameters and biases will be discussed later on in the future lessons. We have this. For example, you have the outputs, which are 1, 2, and 3. So each point is an output or an input. Then for each input, there is a corresponding weight for that. So for example, in the case of one input, we have a zero point 0.1 assigned weight. For 2, it's 0.3, and 3 is 0 negative 0.5, and bias is set to 2. This is computed by, or the output is arrived at with this computation. So input 0, 0 means here 1 and 0. This indices 1 and 0 0.1. These are the values in the index 0. Then times weight 0 plus, then 2 and 0 0.3, and then plus the product of 3 times negative 0 or negative 0.5, and then we add the bias after we get the results of all of these multiplications or additions. When we print the results, we will get 1.2. So now it's actually very advisable if you're going to convert all of these things into a function and then making this one into a function, then we have these results. So we have defined a single neuron output. Then we have these parameters, inputs, the weights, and the biases, or the bias, because these are what we need in this formula or in this function. Then we initialize the output as the bias. So output is equal to bias. Then we iterate over the inputs and weights, and then we multiply and add to the output. So for I in wins lin inputs, then we have the output plus equals to, or which means every time we add the input and the weights, then it iterates over the input and weights, and then we return the output. Then we give the values of both inputs, weights, and bias, and then we plug in these values into our function, and then we get these results 1.2. So this one at the bottom is just actually a rounding off of the values, so that's why we would have 1.2, which is actually equivalent to this one, the first one that we have.
Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like machine learning essentials, deep learning mathematics, and a lot more. Here, you can always learn an upskill for free.